In this video, we will talk about what exactly artificial intelligence is. At the end of this video, you should have an understanding of the different definitions of artificial intelligence and understand a bit about its history. Artificial intelligence, or AI, is being talked about a lot right now. Probably you've got a rough idea of what AI is yourself, for instance, a learning algorithm or a very advanced robot. At its core, artificial intelligence is about making artificially intelligent systems. In other words, smart computers. But what exactly makes one computer system intelligent and the other not? What defines when something is AI? This is actually a difficult question, which even many people working in AI don't fully agree on. To understand what AI is, it is helpful to understand the history of AI. So that's where we'll start. The history of AI starts in the 1950s, and the term artificial intelligence was coined in 1956. This was the era of the first computers, and very quickly the notion of thinking machines appeared. If a computer could solve a mathematical problem or a logical problem, could it also learn to be as intelligent as people? One of the most important people in the history of AI is Alan Turing. He was a mathematician and a codebreaker during World War II, who worked on computer systems to help with codebreaking. In 1950, he published an article which opened with the question, "Can machines think?" In this article, he argued that this question is quite difficult to answer as thinking is so hard to define. For this reason, he proposed to change the question, and he introduces the imitation game. The imitation game involves 3 agents, one human interrogator, one human player, and one computer player. The interrogator can ask questions to both players, who will then reply. The interrogator cannot see the players to determine which is human and which a computer, and they need to decide this purely based on the written answers to the questions they ask. Turing proposes to replace the question, "Can computers think?" with the question, "Can a computer conceivably convince a human interrogator that they are human?" In this article, he proposes that this is fundamentally possible. Currently, we call this interrogation game the Turing test. It's a test to see whether a computer could convince a human that they are human themselves. In the 50s and 60s, research on AI started optimistically and often with a symbolic approach. This means that the attempts at reasoning and intelligence started from representing things with symbols, for instance using logic. Often, small and closed-world problem tasks were used. At the same time, people started to take inspiration from biology and started to try to emulate how the brain works in neural networks. However, by the late 60s, it turned out that AI wasn't progressing quite as quickly as some has hoped. Many real-life problems turned out to be quite difficult to solve in practice, and often solutions which worked in small, closed-world settings couldn't be translated to the real world. In the 70s, most people working on AI worked on knowledge-based systems. These were mostly based on rules, so logic and maths. Because they didn't try to tackle large problems but rather focused on specific domains, they tended to be the most successful. In the 80s, people started to return to the work on neural networks in this quest to make systems learn and think like humans would. This was a very different approach from the knowledge-based systems and based in connectionist models rather than symbolic ones. A big question still today is whether human thinking is based in neural connections or in symbols. And the current view is that in AI, these approaches are complementary rather than competing with each other. In the 90s, AI research was maturing, and solutions more often were built on previous theory with more solid evaluation methods and more real-world applications. Learning remained an important area for research, which was now often based solidly in mathematical theories. We also see the rise of the agent approach. People started looking at AI systems not as being one-trick ponies, but as whole agents. So agents which operate in an environment, experience things, and in turn influence their environment by their behavior. From about the year 2000, we see that a rise in both the amount of data sets and computer power really gave a boost to data-driven approaches in AI, and learning in particular. The application domains where AI is directly relevant have grown immensely with these developments, and the promises of AI seem endless. At the same time, we also increasingly become aware of the limitations and risks of applying data-driven methods. Good examples are the bias in datasets and the concerns about data privacy, the black box nature of many methods, which makes it really difficult for humans to understand and monitor AI's decisions. For a long time, the Turing test was seen as a test of whether a computer system was AI. However, there's also people who object to this definition. Turing basically poses that if a computer can perform a basic written question answering task, it is intelligent. Since the 1950s, our thoughts on what intelligence in computers is has changed, and scientists do not still fully agree. On the slide, you can see 4 main categories defining what artificial intelligence is. The category which would correspond most closely to the Turing test is that of acting humanly. A computer is considered intelligent if it can behave like a human. The first definition specifies that this only holds for human behavior which would require intelligence. And this already assumes that some behavior by humans is not intelligent. The other definition in this group is also interesting because it specifies AI as making computers perform those behaviors at which humans at the moment are better. And that implies that in practice, truly achieving AI is impossible. After all, once a computer becomes better at something than a human, it stops being artificial intelligence. This sounds a bit odd, but it fits with our shifting ideas of what AI is. When the first chess-playing computers were developed, this was considered a feat of AI. Nowadays, we don't really see a chess-playing algorithm as typical for AI at all. A second way of defining what AI is to instead consider thinking humanly. And these definitions pose that it is not so much the behavior as the thinking which is important in AI. And specifically, AI is to make computers think like a human. The idea that activities such as decision-making and learning are a part of AI is very intuitive. On the other hand, you could question what it means to think, and some people argue that a lot of human thinking is actually quite irrational. This brings us to the other 2 definitions. These definitions step away from trying to emulate human intelligence and instead focus on rationality. Rationality describes the ideal decision or thinking, the right way given what knowledge you have. So, rational thinking doesn't try to recreate human thinking, but it focuses on thinking in a rational and ideal way. The final category is acting rationally. Here, instead of focusing on thinking, the focus is on behavior again. AI is to make machines behave in an intelligent manner, to make the right decisions. Of course, these definitions do again give rise to the question of what constitutes as intelligent behavior. This question doesn't have one answer, and that lies at the heart of why AI is so difficult to define. To conclude, there is no single definition of artificial intelligence. AI started as a quest to make computers smart, which initially was mostly seen as making them more human. However, increasingly there has been an approach to make them more rational, and whether we want to focus on intelligent thinking or behavior is up for debate. Moreover, our notion of what AI really is has changed over time. And you could even say that as soon as we truly understand how we can get a computer to do something we previously considered intelligent, it stops being AI. Many of the groundbreaking AI applications of the past are now no longer considered very intelligent. So who knows how our perspective on AI will keep changing in the future. Over the last 70 years of AI research, different approaches and techniques have been promising, and we've seen summers and winters of AI. Periods in which the sky seemed the limits, and periods in which we suddenly found the limitation of what current techniques could really do. At the moment, we are in a summer of AI, fueled by big data approaches. Yet, there's also a growing awareness of the limitations of the state of the art. Current AI research is increasingly interested in how we can make computers smart, not just in a rational way, but also in a way which takes into account the human society in which it is embedded.